All right, hello everybody. I'm going to show you how to do some of the harder problems, or the problems that I think you should definitely know how to do. Let's start with problem number one. Problem number one, let's pick, this is problem C, the one I have written down. And so we're going to do the difference quotient. So let me show you how to do that. So I'm going to do, this is the difference quotient, right? And so first, x plus h, the f of x plus h, I'm going to plug in for x. On the function, I'm going to plug in x plus h, right? So x squared, instead of x squared, I'm going to plug in x plus h squared. That's what x is, right? And then minus 2x, again, instead of x plus h. Then all we have to do is simplify and do all that work. And then minus f of x. So minus f of x. F of x is x squared minus 2x. I'm using a different color so that you guys can all see. All of this divided by h. So again, this is f of x plus h. And this right here is f of x. F of x plus h minus f of x. All I have to do now is simplify all this. So x plus h squared. Make sure you guys know this is what it means. You're going to multiply h times x. Again, it's another hx. xh, the same thing. And so you're going to have two of the middle ones. And that's what you get when you do x plus h squared. Okay, just so that everybody knows. All right. So we are going to get x plus h squared is x squared plus 2xh plus h squared minus 2 times x minus 2h, and then minus x squared plus 2x. All of this divided by h. Okay, now let me delete all these. This is what's going to happen a lot of the times. These will cancel. Negative 2x plus 2x cancels. What we have left with is and then h's cancel, and then h squared over h is just 1h, and this is what we have. All right, and so when you do the difference quotient, you need to plug in x plus h for every x, simplify all that, and then just do a little bit of algebra to finish the problem and get your solution. And that's it. All right, so that was number one. I did C. Let's try another one. Let's move on actually to 2 or 3 are very similar problems. So I'll just do one of these. Give the coordinates of the vertex. Let's do 2. The coordinates of the vertex, this is A. The vertex is H and K. So this one is your H, this is your K. Notice the H is always opposite sign. So instead of negative 23, it's positive 23. And the K is negative 20. So again, this is the vertex. Explain how the graph is transformed from the original. So the H is a horizontal transformation. horizontal shift. So moved 23 units right, 20 units down, and then stretch of 5. Stretch factor of 5. That's this number here. Okay, and that's what it does. If it's negative, it flips the graph, right? So number 3, you guys can try, so you guys can practice. But that's number 2. Number 3, you can practice, like I said. Number 4 and 5 are very similar. All we have to do is change, kind of like 2 and 3. Okay, say what the transformations are and write the equation, right? The original is this one, so we just have to do the transformations that they tell us. Okay, so let's go ahead and get going on number 4. So it says here is reflected with respect to the x-axis, so it gets flipped, so that means it's a minus. Compressed by a factor of 1/3, so it's not stretched, it's compressed, and it's shifted left 3 units, left and right is on the x, and then up 5 units, that's the number outside. It's kind of like the parabola of the x squares, like the one we did 2 or 3, problem 2 or 3. Okay, so if it's reflected, that's the minus sign. Stretch, compressed by a factor of 1/3, the 1/3 in front of the function, and then shifted left 3 units. So you know how we put a +3 here. Remember, that's always opposite. And then up 5 units, that's a +5, straightforward. All right, number 6. I can pick one of these to do. All right, let's pick, let me see, which one should we do? We should do maybe 6B. All right, so every time you guys are doing these, you guys can always try to factor. And if it doesn't factor, you can use the quadratic formula. It's as simple as that, okay? So if I try to factor, let's see, I don't even know if it does factor or not, but I'm going to try. I factor out a 2, a -2 that is. All right, I factor out a 2. Then I try to see if the inside factors, is there any factors of 4? That when I add, I get -2. I don't think so. So factoring doesn't work. All right. So the next thing is to do the quadratic formula. Minus b plus or minus the square root of b squared minus 4 times a times c. All of this divided by 2 times a. Okay, so we have all this. You just go through the process and try to simplify as much as you can. That gives you 8. 8 times 8, -64. The sign is very important there. 16 minus 64. I think that is -48. -16 minus 64, -48. Okay. You're gonna try to simplify this. 48 factors that have a perfect square root. 16 times 3 is 48. I chose 16 because it has a perfect square root. And now what do you guys do with a negative inside a square root? That gives you an I, right? What we can do next is everything is divisible by 4. So this will give you a 1. This will give you a 1i. And under the 4, we don't need to put a 1 under it. So this is as far as we can go when we simplify, okay? So all it is using the quadratic formula. All right, so that was problem 6b. You guys can use the quadratic formula for all quadratic problems. So all of these, make sure it's equal to 0, and then you can use the quadratic formula. Maybe I can do another one really quick. I can do probably C. And why do I tell you this? It's because here, well, what I see is you guys can use the square root method. So here I would divide by 7. And then you would, in order to get rid of a square, use square root. Plus or minus, and then here when you have a negative inside a square root, remember it's an I, right? So it's a 2i. Okay, so that was 6. All right, number 7. Number 7 and 8 are very similar. Let's try one of these. Number 7. The cost function of a product is given by the function there. N is the number of units produced and sold. So N represents the units, and then C of N represents the cost in dollars. What is the domain of the function in context of the application problem? So this is a parabola, right? If you guys were to graph it, you don't need to necessarily, but you know that it's a parabola like that because of the N squared. So you can go to Desmos if you guys need to graph anything, and you just put in the equation there and you graph it so that you can look at it. Okay? So it gives you a parabola. We knew that. You don't need to, it's not part of the problem to graph it or anything, but just to visualize it. The left part of this graph, we don't need it because it represents units. I can't sell and produce negative units. So only from 0 on to infinity, from here and on, right? So that would be your domain. So it is from 0 and on to infinity. Is the function 1-to-1 in the domain? So again, we're not seeing the left part of the parabola, we're just seeing the right side. And so if we do the horizontal line test, it would pass, okay? So again, this parabola, we're not going to see the left side, we're only going to see the right side. And so it would be a graph like this. And if we do horizontal line test, that's to check if it's 1-to-1, it passes. It does. It is 1-to-1. Yes. Passes horizontal line test. Okay. Now here comes the hard part. We need to find the inverse. And I'll show you how to do that. So again, let me go over here to notes. And let's get started on this one, okay? Now, instead of C of N, I'm going to write Y equals, just for now. And then in order for you guys to find the inverse, in other words, you have to solve for the other variable, okay? You have to solve for N. And it says hint, use the completing the square. So let's go ahead and get through that. First, I'm going to move the 2100 to the left side. And then I'm going to, the trick to do the completing the square, it's always going to be half of the B term, half of the B term, half squared. b over 2, half of the b term, squared. Okay, so that's why I chose the b term. The middle term is 12. 12 divided by 2, half of it, is 6. 6 squared is 36. Okay, so that's the very important number that we have to add to both sides. The reason for that is so that we can factor this. The right side factors into n plus 6 times n plus 6. Perfect square. And on the left side, what I can do is I can combine these two. And then I'm going to get 2,000 and what is it? 64. All right. I'm very close to solving for n, isolating n. And so what I need to do is use the square root. When you square root, you need to do plus and minus. But since it's only the right side of the parabola, we don't need to do plus or minus in this case. Okay, and then lastly, I subtract 6 from both sides. And then I get n equals negative 6 plus y minus 2064. All right, this is my inverse, except that now I have to use the correct variables. So the original problem, the y, this was C of n, represents the cost in dollars, and then n represents the units. So now it's going to be backwards, right? So n is going to represent the units. And then the y is going to be, the cost. All right, that's the inverse. It's the inverse for for number 7. And then question D on 7 asks you to use the inverse to find out how many units will be produced and sold if the cost is 3,220. So since you found the inverse already, 3,220, you would plug it in here. Okay, so that was number 7. Plug it in and then just figure out the number of units. Let's see, let's do the next one. So again, 7 is very similar to 8. You guys should definitely try 8 so that you guys can get practice. Number 9, we can try one of these so that you guys can see how it works. We're going to do it in parts, so we're going to graph by hand this piecewise defined function. So a graph will be provided for you guys, and then all you have to do is graph it in there. Okay, I'm making it on my own here. X, I'm gonna graph A. So first, for x's that are less than -2. That's -2. I should see this graph right here, okay? I shouldn't see the entire graph, only for values that are -2 and everything to the left of that graph. So, if I plug in -2, I get 4 minus 1, and I get 3. So, -2, comma 3. This point should be open because it's less than, not less than or equal to, so it's open, and then everything to the left. So let's pick another point, for example, -3, right? Another number to the left of -2, -3. So I'm going to do -3 squared minus 1. So that's 9 minus 1, and that gives me 8. So negative 3 gives me 8. 4, 5, 6, 7, 8. This one here. And then you should label your points. Don't forget, guys. Negative 2, comma 3. And this one is negative 3, comma 8. This is a parabola. The first one is a parabola. Now, you're not going to see beyond this point because you should only see values of x that are negative 2 and to the left. So I don't continue and graph them all this way, the parabola. Only those points, okay? The rest of it, you shouldn't graph it. Okay, let's move on to the next part. The next one is a line. We should all know what the functions are, and that function right there is a line. 3x plus 2 is a line. From negative 2 all the way to 2. I should graph a line only that in those parameters right there. So when x is negative 2, plug it in, negative 6 plus 2, negative 4. So negative 2 and negative 4 is this one. Is this solid or open? It should be solid because of this. All right. The endpoint of this line, it should be when x is 2. 3 times 2 is 6, plus 2 is 8. 2 comma 8 is this one. Should be open or closed. It should be open there because of this. And again, this is a line. And it doesn't keep going because we should only see from negative 2 to 2. So we shouldn't graph the entire line, only this part. Okay, that's why it's called a piecewise defined function. Negative 2 comma, we said it was negative 4, and then this top one is 2, 8. All right, let's move on to the third piece of this graph, and it should be this one. We know that these graphs look like this. Okay, so we know the function. It should be from 2 and on, from here and on. All right, so let's plug in 2. 2 plus 2 gives you 4. Square root of 4 is 2. Okay. 2. Is this solid? It is solid. And then let's plug in let's plug in another one. I should probably plug in a number so that it's a perfect square root. And the next one should be when x is 7, right? Because 7 plus 2 is 9. The square root of 9 is 3. All right. So I will choose carefully here. I will choose 7. 7 plus 2 is 9. The square root of 9 is 3. So 3, 4, 5, 6, 7. 7, 3. And I don't graph the other part of the graph. I only graph from 2 and on. Okay. This is 2, 2. And this is 7, 3. And that's my piecewise. All right, guys. At least you have an example. You guys can give the other two a try and then go on from there. 10, 11, 12 are very similar. Let's do one of these. Maybe let's do 10. So f of x is 3x minus 4. G of x is x plus 4 over 3. What we need to do is first f of g of x, plug in g into f. So this goes in here, okay? So 3 times x, this is where we put the g. We simplify, these cancel, and then the force cancel, and you're left with x by itself. Okay, simple as that. Now what we need to do is the other way now. We need to do g of f of x. We plug in f into g. So x plus 4, instead of x, I'm going to plug in f, and then plus 4 over 4. So the plus 4's cancel. The bottom one, it's a 3. That's where, if you notice g, the bottom, the denominator is a 3. Okay, so the 4's cancel. And then 3 divided by 3 is just x. All right. Since on both compositions you got x when you simplified everything, then that means that they are inverses of each other. Okay, that's question C. Question C asks you, are f and g inverses? Yes, they are. They are inverses because their compositions, f of g of x and g of f of x, is equal to x. Okay, that's how you will know they are inverses. They must be equal to x. All right, let me do 13 for you. I can choose, doesn't matter, A or B. So what we're going to do when we find the inverse, we're going to replace this with y. It's just easier. I'm going to interchange variables. I'm going to solve for the other variable to get rid of the fifth root. I raise it to the fifth power. The fifth power gets rid of the root. And then move the 7 over. And that's my inverse. All you have to do is write it appropriately. This symbol right here means it's an inverse. We found the inverse. Alrighty, guys. Let me pause the video here. I'll make another one to finish up the problems, okay?